Hello everyone. So today in this video we are going to learn binary tree, binary search tree and traversal techniques in a binary tree. So now let us understand what exactly is a binary tree. So a binary tree is a tree in a data structure, as you can see from these three figures. So it is a node which can have no child node. Then it is in the second figure it says that it can be a node which can have at least one child node, or it can be a node which can have at most two nodes. Okay, so this we call it as a node in a binary tree, and these are its child nodes. So here I have one child node, and in the last figure I have two nodes. So these three figures represent a binary tree. Now if you look at this last figure, it looks like a tree like figure. So I have the very top, we call it as a root node. This A would be as a root node, and below this A we have the two child nodes B and C. So we can call this B as my left subtree and the C as my right subtree. Okay, or I can say as a left node and right node. Okay, so this is a binary tree. Talking about binary search tree. So what is a binary search tree? It is also called as BST. So a BST or a binary search tree has to be a binary tree first. Okay, which means it must satisfy all the three conditions what a binary tree has in order to make it. Next, apart from this, so it is a binary tree, and second most important thing is that the left subtree, the value of the left subtree should always be less than equal to the root node, and the value of the right subtree should always be greater than equal to the root node. So that is what is the condition for a binary search tree. Two conditions. First, for a binary search tree, for a tree to be in a binary search tree, it must be first a binary tree, and the second point is that the left subtree should be less than equal to the root node, and the right subtree should be greater than equal to the root node. So as you can see over here, the value 1 is less than 3, and here the value 4 is greater than the root node, which is 3. Now moving on to the traversal techniques. So we have different traversal techniques as in order, pre-order and post-order. So why are this traversal technique used? So suppose in this binary search tree, this is level 1 binary tree. I mean to say it like this is L0 and L1. So this is level 1 binary search tree. Now if the binary tree is still level 10, okay, so starting from L0 to L10, and if you want to traverse from the last node to the last left subtree node to the right subtree by moving in upward directions, going to the root and then coming back to the right subtree. So there are these different traversal techniques, in order, pre-order, post-order, which are used in order to find any node in a given binary tree. So let's understand what are these nodes. So we have the very first, which is in order. So the path for in order is this, you have to remember, it is very important. So in order path is left, root, right, which means starting from the left subtree, then move to the root and then to the right. Pre-order starts from root, so this root, then we have left and then we have right. So this is the path for pre-order. Next we have is post-order, which starts from left, goes to the right and then goes to root. So these are the fixed path for in order, pre-order and post-order, based on which you will get numericals or sums to solve in the examination. So let us have implement this traversal techniques on a given binary search tree. So now we have to find the in order, pre-order and post-order as shown over here for this given tree. So we have so there is a representation in order to find this in order, pre-order and post-order. So let's assume this as my node. So I will mark here to the left of my node, to the bottom of my node and to the right of my node. So this left side would be, the left side of my node would be the pre-order, the bottom part would be my in order, and the rightmost part would be my post-order. So whenever you get a diagram or tree diagram in your exam, you first have to mark this particular points on your nodes. So let us do it over here. Well, we'll first draw the diagram, tree diagram, 3, then we have 1, and here we have 4. So we have to find in order, pre-order and post-order. So let us do a marking for pre-order first, and we'll draw the flow exactly how it goes. So this is how my flow goes. So first of all you have to draw this path and then mark it. So we are doing for pre-order first. So to the left, so this is my node, to the left, following the path, to the left side of my node and follow the path. To the left side of my node, follow the path. From here it will go here and then over here, only to the left side of your node. So my pre-order would be, first number is 3, then I have 1, and then I have 4. Next, the in order part. So again follow the path and mark at the bottom of your node. So follow the path at the bottom of your node, mark over here, again follow it, mark over here. So in order starts from 1, then I have 3, and then I have 4. So this is my in order. Now next is post order. So post order is, the marking is to the right of my node. So again follow the path and mark on to the right of your node, over here and this over here. So starting from 1, then I have 4, and then I have 3. So in this way you find out the in order, pre-order and post order of a given tree. So this was just a small tree and a small example of it. Now we'll see a bigger tree, and let's try to find out the in order, pre-order and post order. So now we have here a given binary tree, and we have to find the in order, pre-order and post order. So we'll apply the traversal techniques and we'll get the answer for this particular binary tree. So the very first one is in order. So how does in order goes? It goes from left, root and right. So this is a root node 1 of this binary tree, and we have this left subtree and right subtree. So moving towards the left, so we have to the left of 1 is 2, but we'll not write the value 2 because 2 is root of some child node. Okay, so we'll keep on traversing till we do not reach across any leaf node. Leaf node means a node which does not have any child nodes. So moving to the depth of this left subtree, we have the value as 4. Okay, so 4 is been written. Now 4 has what? 4 has one more root node as 2. So we'll travel to the left subtree and we get after 4 value as 2 because it says left, root, right. So left node is completed. After that we will go to the root. So root of 4 is 2. So we'll write here 2. Now again, now root of 2 is what? 1. So we'll write 1 over here. So the left part is completed. Then what? Right. Left, root and right. To the right of my tree, I have right of my subtree, I have the node as 3. But I will not write the 3 value over here because 3 is again having child nodes 5 and 6, and 3 becomes the root node of 5 and 6. So if I focus on 5, again I will not write 5 because 5 is having child nodes 7 and 8. So we'll travel to the left of this right subtree and we'll reach to a node which does not have any child node, which means we'll travel till we not reach across any leaf node. So focusing on this particular subtree and moving on to the traversing through the left side, we reach across a leaf node which is 7. Okay, so I have completed this. So left, root, right again. So left, then I have what? Root, which is 5, and to the right I have 8. Okay, so I have completed this subtree. Now let's deal with 3, 5 and 6, this subtree. So left, root and right. 5 I have already written, I will not write 5. Root of 5 is 3 and then right is 6. So my in order is 4, 2, 1, 7, 5, 8, 3, 6. Next, pre-order. How does pre-order goes? Root, left, right. So root is what? 1. I'll directly write the root. First value is root. So I'll write my root value is 1. After 1 I have the next value root I have written as 1. So where do I have to traverse after my root? Left or right? I have to traverse left. Root left, right. So I'll go to the left of my root node. So I have next value as what? 2. And you can see that 2 is what? Root node of its child 4. So I will directly write 2 over here. Why I have written 2 and not 4? Because in pre-order sequence it says root first value. Root will be the first value, then left and then right. So I'm traversing in left side, but as I traverse to the left side I come across a node which is a root node of some child node. So that is the reason I write here 2, because as per sequence root is the first node which I have to write whenever I traverse in any of the side. So 2, and then I will what write? I will write at 4 over here. Root left right. Root, and to the left of again this root node is what? 4. So I have written 4 over here. So this part is completed. Coming to the right side now. So root is done, left part is done, now right side. Now to the right side I have value as 3, and check whether this 3 is a root node or not. Yes, it is a root node. So I will directly write it over here. After 3 I have to traverse in which direction? Left or right? I have to traverse in left direction, because root then left. So to the left of my 3 I have what? 5, and again 5 is a root node of 7 and 8. So I will write 5 over here. Now again from 5 I have to traverse in left direction. So to the left of my 5 I have what value? 7. I will write here as 7. So root left value is covered. And now coming to the right side. Since there is no child nodes from 7, I am coming it to the right side now. If there would have been any child nodes after 7, I would have proceeded in the again left side and then completed with its child node, and then I would have come to the right side. So 7 is done. 7 does not have any child nodes. So come to the right side, which is 8. So after 7 I will write 8 over here. Root left right, completed. This subtree is done. Now coming to this subtree, which is 3, 5, 6. So 3 was already done, 5 was already done. I will write what now? 6. 3 is done, 5 is done. Root left, right side was 6. I will write 6 over here. So this is my pre-order sequence. Talking about post order. So in post order, how does it goes? It goes from left, right and root. So what is my left side? So from root I have to traverse to the left side. First is left side. So left side would be what? Over here. As you can see, to the left I have 2, but after 2 I have one more child node. So I'll traverse to what? Which node? 4. So first it would be 4, left side would be 4, then again 4 is having a root which is 2, left right root. So I'll cover this left side first, 4, then 2, okay, 4, 2, then I have what? Left side is completed. I'll come to the right side, which is 3. Again 3 is having the left and right child nodes. We'll process them. So we have over here 3 value. So left side of 3 is what? 5, but I will not write 5 because still 5 is having again child nodes 7 and 8. So directly I'll come to the leaf node, which is 7. So left side is done. So there is no more child nodes. So I'll proceed to the right side, which is 8, left, right, and then root, which is 5. Okay, so this subtree is done. Coming to this, left part is done, 5 is done. Right side, which is 6, root, which is 3. So entire left side of root node 1 is done, entire right side of root node 1 is done. So left side is done, right side is done, left, right and root 1 over here. So that is how in order, pre-order and post order has been written. Now if let us try to find out through another technique which we have learned, which is nothing but the marking point over the node. Okay, so we have here mark for pre-order, in order and post order. Okay, so for let us first draw a path. So let us find in order with the help of placing a marking on our node. So for in order, the marking is at the bottom. So following the path, we'll mark it to the bottom. 4. Then we'll have 2 also, because in this after 4 it covers 2 also in the marking. Then we'll have 1, we'll have 7, 5, then 8, 3, 6. So if you check, we have 4 first, then 2, then 1, then I have 7, 5, then 8, 3 and 6. Now next is pre-order. For pre-order marking, we have to the left of our node, following the path 1, 2, 4, then I have 3, 5, 7, 8 and I have 6. So if you check 1, 2, 4, 3, 5, 7, 8 and 6. Now for the post order, we have marking to the right side of our node. So if I follow the path, I get 4, then 2, then I have 7, I have 8, 5, 6, 3, 1. So if I check 4, then 2, then directly I have 7, then 8, 5, 6, 3, 1, 6, 3, 1. Okay, so you can solve this, find out the path using both the techniques, through this traversal techniques and then through the marking of nodes. So using both the techniques, you can cross verify your answer. So yes, now if this year it was given a binary tree, so what if there is no binary tree given to us and there are only numbers or sequence of numbers in the question? Then what to do? Then we have to find out or create a binary tree first, and then we can find the in order, pre-order and post order. So let us have a look on such an example where there is no binary tree given to us and there are only numbers given in the question. So now we are going to see a question where there are given a sequence of numbers and we don't have a binary tree. So the given data is, we have given in order values, which is 2, 5, 6, 10, 12, 14 and 15, and we have pre-order values are 10, 5, 2, 6, 14, 12 and 15, and we have to find post order. Okay, so this is the question given to us: in order, pre-order, and we have to find the post order. So what we have to do is we have to construct a binary tree first. So we know how a binary tree looks like. We have a root node, and then we have a left subtree and we have a right subtree. So this is how a binary tree looks like. So binary tree needs to be constructed from the given data, and what we have is in order sequence and pre-order sequence. So we need to find the root node first. And how will we find the root node? If we check the in order, we in the traversal techniques, how does in order goes? It goes from left, root and right. So if you can see in order, the root is in between. So in this sequence, the root is somewhere in between these numbers, but we do not know where exactly the root is, right? So we'll check for the pre-order. So how does pre-order goes? Pre-order goes in this way. We have root, left and then right, which means the root is at the start position. So we got the root from pre-order. Okay, so we'll follow the sequence of pre-order and construct a binary tree. So the first value in pre-order, which is our root, is 10. Now look for this 10 value in your in order. Okay, so this 10, where does it come in order? It comes over here. So 10 would be my root. Okay, and next this left side of 10 in order would be my left subtree, and the right side would be my right subtree. Okay, so over here this 2, 5 and 6 are my left subtree for the root node, and 12, 14, 15 are my right subtree for the root node 10. Proceeding further, again I will check in the pre-order the next root, which is 5. Okay, so check this 5 again in order sequence. So where do I have my 5? I have my 5 over here. So the next root would be 5. Let me rub this. So my next root would be 5, and the left subtree and right subtree of root node 5, we have to find out those subtrees. So if you check in the in order sequence, to the left of 5 we have what value? 2. So 2 would be my left subtree. We were having here values as 2, 5 and 6, right? So to the left of my 5 I have value what? 2. So I will put 2 to the left of my root node 5, and to the right of my 5 I have the value as 6. 2, 5, 6. Well, there are many values, but we were having here only 2, 5, 6. So to the right of my 5 I have value 6. So I will put here value 6. So this is my left subtree and right subtree of root node 5. Similarly, next what we have is 2. Next root node is what? 2. So we have already completed with the 2. We will not touch it. Next what we have is 6. Again 6 is done. So we'll leave this. Next what we have is 14. So 14 is the next root node. So we have for 12, 14, 15 here. So 14 would be the next root node. So I will write here 14. Okay. Next after 14 I have what? 12. So check 12 in order sequence. So after 14 I have my before 14 I have the value 12. To the left of my 14 I have what? 12, and to the right of my 14 I have what? 15. We were having your values as 12, 14 and 15. So to the left the value would be 12, and to the right the value would be 15. So this is how you construct a binary tree first from the given pre-order and in order. So once the binary tree is constructed, so we have completed with the entire sequence. Now we have to find a post order. To find a post order, what we have to do is we have to follow a path or draw a path. So let us first draw a path. So this is the path, and we have to make a mark sign on our node. So the marking would be to the, since it is post order, it would be to the right side of my node. So following this path I will mark to the right side of my node. Okay, and from this marking I will find my post order. So the post order is following this path. First is 2, then I have 6, then I have 5, then I have 12, then I have 15, 14 and 10. So this is my post order sequence which I've got. So the given data was in order and pre-order. There was no binary tree, and we have to find post order. So what we did, we looked at the pre-order, how it flows from root left right. Why not in order? Because in order the path is left root right, root is somewhere in between which we cannot find. That is the reason we went for pre-order. So in a given question they would either give you in order pre-order, or they would give you in order post order and tell you to find the pre-order, but in order would be given to you in the question. Okay, so we look for pre-order since we got the root at the very start. So this value we searched in the in order sequence over here, and we got our root node 10 in order sequence. So this left part would be the left subtree and the right part would be the right subtree of root node 10. Proceeding further, the next root node was 5. We checked for so in left subtree the sequence was 2, 5, 6. So 5 became a root node, next root node, and then the next next node was 2. So 5, we had 5 over here. To the left of our 5 we had 2 value, and to the right we had 6 value. So left subtree was 2 and right subtree value came as 6. So 2 and 6 were done over here. Next value was 14. So to the right of my right subtree of my root node 10, I had this value 14. So 14 over here, and the values of left subtree and right subtree of 14 were 12 and 15, as you can see in the given in order sequence. 14 is over here, to the left of 14 I have 12, to the right of 14 I have 15. So 12 became my left subtree and 15 became my right subtree of root node 14. Later on I drawed a path and just made a marking for post order, which was to the right side of every node, and following the sequence I got my post order value. So this is how we find it, the in order, pre-order and post order. So yes, that's it from this video. Thank you so much for watching.